Welcome back. Now, in this third part, we are going to study about the most important point in this chapter, that is the equation of tangents. We are also going to study that how a straight line can interact with the curve, that is the ellipse, and what are the different conditions. We are also going to derive condition of tangents in this parts. So let's start.
Position of a line with respect to ellipse. Now again we have seen that different curves and line can interact in a different manners. For example, a straight line can be a tangent to the curve, can be a chord to the curve, or they may not interact. So let's start by looking at what cases are there. The first case is when the line intersect the curve at 2 points. So that is called a chord. Now the second case can be when the line just touches the circle and leaves. We know this case is a tangent. Third case can be where a line neither touches nor intersects. So this is first case, second case, third case. In the first case, the line is a chord to the curve. In second case, the line is simply a tangent. In the third case, the line is a nothing, or they are not interaction. So nothing means it's neither a chord nor a tangent. That means that it's not interacting. Now how can we find out that mathematically a line is what to the curve? Out of these three cases, how can we mathematically prove that a line is either chord or tangent or it's not interacting? Let's say that we have the curve or the equation of ellipse as x square by a square plus y square by b square is equals to 1. And let's say that we have a variable line that y is equals to mx plus c. In order to find out that how the line and the curve are interacting, we need to put the equation of line in the curve and we need to solve. How? So let's start this analysis. So if I put the value of straight line in the curve, then I will get x square by a square plus y square. Instead of y, I am putting the equation of line, that is mx plus c square divided by b square is equals to 1. If I take the LCM and if I simplify, then I am going to get b square x square plus a square m square x square plus 2a square mcx plus a square c square is equals to a square b square. So I have done nothing, I have just taken the LCM and I have opened this whole square and I am trying to solve it to get the rate. Now I can clearly see that this equation is a quadratic in x. It's a quadratic in m as well. So if it's a quadratic in x, then what do this quadratic in x means is that now whatever number of solution this equation gives us, that means that are those possible values of x. For those values of x, we can get corresponding values of y. So either we can get no value of x, one value of x, or two value of x. Now with respect to that value of x, we can get y. That means number of values of x that we can get here is actually the number of coordinates on which the line and point are interacting. If I simplify this, then I am collecting the coefficient, then b square plus a square m square of x square plus 2a square mcx plus a square of c square minus b square is equals to 0. Now this is the quadratic equation that we were talking about. Now what we need to do is that if the discriminant of this equation is greater than 0, what does this mean? This means that we have two values of x. That means we have two solutions, or the curve is interacting with line at 2 points. 2 points, that means it's a chord. These are those 2 points. So in this by this method you can also get those 2 points as well, specifically that what are those points in which the line and the curve are intersecting. Second case is d equals to 0. That means the line touches the curve at 1 point only. So if this is your curve, then this is the interaction. That means in this case only one value. That means one solution, or this case tells us that the line is a tangent. If the line and curve do not touch or intersect at any of the point, that means D is less than 0 or they don't have any common solution. No common solution. That means the line is neither intersecting and it's not touching. So this is the analysis that you can do with the help of these 2 points. Let's move. Now, equation of tangent. I would like to find out what is the equation of tangent. I am interested in equation of tangent. So we know that if this is the ellipse, then this is the tangent, that is the line that is touching the circle at the curve at exactly one point. So we know that the equation of ellipse is given by x square by a square plus y square by b square is equals to 1. Let's say that this point is x1, y1. That is, the line is touching the ellipse at this point x1, y1. If I know this point, then I can find out the equation of slope. Sorry, the value of slope. How? By differentiating the curve and putting that value, that coordinate in this differentiation. So if I differentiate that, I am going to get 2x by a square plus 2y by b square into dy by dx, and then differentiation of constant is 0. I am interested in this dy by dx at x1, y1. Why? Because that will be the slope of the curve at that point, or you can see the slope of tangent. By this method, dy by dx comes out to be minus x by a square into b square by y. Now again, I want dy by dx at x1, y1. That means minus x1 b square by a square y1. Equation of tangent can be simply written as y minus y1. Now because we have the slope and we have one point, so by slope and point form, y minus y1 is equals to m, that is minus x1 b square by a square y1 x minus x1. If you simplify this, then I am writing the simplified form. You are going to get x1 by a square plus y1 by b square is equals to 1. So this is the form t is equals to 0 as well. So remember, this is the equation of tangent where x1, y1 are the point which is lying on the curve. So if you know any point on the curve, then by putting this point in this equation, you can get equation of tangent at that very point. Equation of tangent at parametric coordinates, for example, instead of writing them x1, y1, I can also write them as a cos theta comma b sin theta. So if these are the points that I have assumed, then equation of tangent in parametric form will be x cos theta by a plus y sin theta by b is equals to 1, as one of the a will cancel the a squares and one of the b will cancel 1b from the b square. So this is the equation of tangent in parametric form. This is the equation of tangent in point form. Remember, the point lies on the curve. Now we will move to the very famous thing, that is the equation of tangent in terms of slope or condition of tangency. Remember that whatever previous thing we have done, it is the point form. Equation of tangent from any point which is on the ellipse. So don't get confused what is the point form and what is the slope form. Now we are going to derive the equation of tangent in terms of its slope, that is m. We are going to keep m here. This is also called as condition of tangency. Suppose that we have an ellipse like this and there is a tangent to the ellipse. Now the equation of tangent to this ellipse, x square by a square plus y square by b square is equals to 1. It has a slope m. So for example, if I know that I have the slope, or if I have a slope which I choose randomly and I want equation of tangent with that slope. So you are deciding the slope and the equation is giving you equation of tangent with that slope. So equation of tangent will be given by y is equals to mx plus minus square root of a square m square plus b square. Remember, your value of m has to be finite. You can't put any value of m and you just solve. So this is the equation of tangent. That means the condition of tangency is y. We know that a straight line is y is equals to mx plus c. So if this straight line is a tangent to this curve, that means your c has to be plus minus square root of a square m square plus b square. So this is the condition of tangency. So let's derive it. Let's derive the condition of tangency. So again, we'll go by the same method which we followed in differentiating the lines, that which line is what. we have x square by a square plus y square by b square is equals to 1, and we have the line y is equals to mx plus c. If I satisfy this line in this equation, then I am going to get x square b square plus a square of mx plus c whole square is equals to a square b square. If I simplify it, I am going to get b square x square plus a square m square x square plus a square c square plus twice of a square mx c is equals to a square b square. I have just opened the whole square. Now I am collecting the terms. As we already know that this is a quadratic in x, so I am going to collect the x square terms, that is b square plus a square m square. Then I am going to collect the x term, that is twice a square mcx, and then the constant terms, that is a square c square minus b square. Now this is the quadratic equation in x. We know that for the condition of tangency, discriminant has to be equal to 0. That means b square minus 4ac of this quadratic equation. So if I do the discriminant equal to 0, that means twice of a square mc whole square, that is b square, minus 4 times a, that is b square plus a square m square, c, that is c square minus b square of a square, is equal to 0. So this is the condition of tangency. Now we just need to simplify. That means this will become 4 a to the power 4 m square c square minus 4 a square. This becomes b square c square minus p to the power 4 plus a square m square c square minus a square b square m square is equals to 0. Now we need to cancel the things out. Which are the common things we need to cancel out? 4a square and 4 can be cancelled out. It remains a square m square c square positive, a square m square c square negative, cancels each other out. What we have got is here is b to the power 4 minus b square c square is equals to a square b square m square. That means I can cancel out one b square as well from the terms. That means b square minus a square m square is actually equals to c square, or c is equals to plus minus square root of okay, so this is also positive. This one is also positive because this is minus minus plus and there is also this minus. So this minus minus also plus, and if it goes on the other side it becomes minus. So b square plus a square m square is equals to c square. That means c is equals to a square m square plus b square. So this is the required condition of tangency or the value of mass. So this is the derivation, and you need to be careful with the signs, and but the method goes like this for any curve and for any tangent. So for example, if you don't have the ellipse but you have any hyperbola, circle, or any other curve, and if you want to derive the condition of tangency for that curve, you can follow the same method. Put the equation of straight line in that curve and try to solve. Try to get a quadratic or cubic, whatever you get, and try to solve for it. Now we'll move and we'll check our concepts. The question says that we need to find the common tangent to both the curves. Now these are very good questions, and these are kind of favorite points, that combining multiple topics to form a question. For example, here they have combined a parabola and an ellipse. So y square is equals to 4x. If this is the parabola, then from the condition of parabola we know that y is equals to mx plus minus a by m. This is the condition of tangency or equation of tangent in slope form for parabola. For for ellipse, we know that it's y is equals to mx plus minus square root of a square, that is 8, m square plus b square, that is 2. Now these two equations will represent the same equation only if their constant values are same, because the rest of the equations are identical. That means plus minus a by m has to be equal to plus minus square root of 8m square plus 2. Also remember that this is y square is equals to 4ax form, that means a is 1. So if I whole square and put the value of a, that is 1 upon m square is actually equals to 8m square plus 2. If I cross multiply and solve for it, I'm going to get 1 is equals to 8 m to the power 4 plus 2m square. That is 8 m to the power 4 plus 2m square minus 1 is equals to 0. If you solve for the value of m, we are going to get m square. Treating it as a quadratic, I am solving this equation. So I am going to get m square is equals to minus 2 plus minus root of 4 plus 8 for the 32 divided by 16. That means my m square value is minus 2 plus minus, this is 36, that means 6 by 16. So I got m square as minus 8 by 16, or if I add it, then 4 by 16. Obviously m square cannot be negative, so we get m square is equals to 4 by 16 or 1 upon 4. That means m is actually plus minus 1 upon 2. So the equation of straight line transforms into y is equals to 1 by 2x plus 1 by 2, or y is equals to minus 1 by 2x, and then the m is on the bottom, so it will become 2 and minus 2. So these two are the equation of common tangents that we need to find out.
Meanwhile, if you have any doubts, you can log on to askIITians.com and you can go to the discussion board. On this discussion board, you will form a form on the right hand side. Select the category in which category your question falls, post your question and get an answer. Here, the experts of Ask IITians will answer all your queries within 24 to 48 hours for free. So this is it for this part. Now I hope you have understood how I have derived the equation of a tangent and the condition of tangency. Remember, the condition of tangency is very important. So we have reached to we have ended actually the half of this chapter, and I hope that you are enjoying. In the next part, we are going to start with the pair of tangents and equation of normals.